Welcome on the KIN-MATICS channel. Today we want to look at the theorem. If G is invertible and f of g of x is equal to h of x, then f of x is equal to h of the inverse of g. It is a theorem that I've just developed. There are so many problems going on social medias, mathematical platforms, and others calling for problems which require to apply this fact. However, many people have not been realizing it, so I'm coming up with a theorem to generalize whatever they have been writing about. Let's start with the proof of the theorem. We are saying that since G is invertible, then there exists an x in real numbers, such that if x is equal to g of x, then x is equal to the inverse of g of x. We're saying, however, we say that f of g of x is equal to h of x. So at a point where x is equal to g inverse of x, when you substitute for x, you find that f is now equivalent to g operated with the inverse of x. And of course, we're substituting for x both sides. So you find here when you operate these inverses, you get x, and you end up having h of g of x. Well, this completes the proof for the theorem. It is just proved under 2 lines. Very simple theorem, but with a lot of applications. I wanted us to look at this example. If f of x is equal to 1 plus exponential x, equivalent to 2 plus x, then find f of sine x. Of course, I said it by saying let g of x be equal to this. Then take the inverse of that function, and you end up having ln of x minus 1. So it implies that when x is equal to ln of x minus 1, when you substitute here, you end up having f of x equivalent to that. However, they wanted us to find f of sine x. So at a point where x is equal to sine x, you find that f of sine x, you just need to substitute where there is x sine. So you end up having that. This is what they wanted us to get. Simple like that. This theorem has a lot of applications. You may try many problems involving this. If you found the video important, please subscribe and share with a friend. Don't forget to leave a comment for us. Thank you for watching.